Alright everyone, welcome back. So now we've got sound effects and voices, so now let's move on to making music. Now, we're going to use the audio manager, but we're going to expand it a little bit. And we're going to have two separate classes that we'll need to make the most of this system. So the way that we're going to handle music is we're going to handle ambience and music through the same methods. Ambience will just be a type of music track. And speaking of tracks, tracks are going to be what will play our music. So we're going to have two other classes to go along with our audio manager. We're going to have audio channels, which means for an audio channel, each channel can have one active track on it. And that track is the one that plays. If we try to play another one, then the active track's going to fade out, and the new one is going to become the active track. So by having multiple channels, we can have multiple songs or multiple different tracks playing at once. So channel 0 could be ambience, channel 1 could be music, like that. And then we'll have our audio tracks, which will actually be responsible for playing the music inside of those audio channels. So let's go ahead and create the first C# script for our audio channel. And then the next one is going to be for our audio track. So in our audio manager, we need a way of keeping track of all of the audio channels that have been created. And each audio channel is going to be referenced with its index, or what channel it's on. So we're going to define all of our channels within a dictionary associated with those channel values. So this will be a public dictionary, and the first value is going to be the channel, which will be an integer, or the channel number I should say, and then the next value is going to be the actual audio channel. And we're just going to call this our channels, and set that equal to a new dictionary. We're also going to want to define a default speed at which our tracks transition in and out. So we can make this a public constant float for the track transition speed. And that is simply going to be 1 starting out, but we can adjust that if we need to. So in our manager, if we want to play a song or ambience or something, we're going to call a function that returns an audio track to play that sound. So we'll make ourselves public audio track return type called play track. That's what songs and ambience are going to be called. They're going to be tracks. So we first need a audio clip or something. We need something to actually play for this song. So we can do like we did for our sound effects. We can start with a file path that can be loaded from resources and some variables that we might use. So as I said, my ambience and my music is going to be on the same audio mixer, so I'm not going to bother defining that in a parameter here. But what I do want to know is, are we looping? By default, that's going to be true. And I need to know the channel for this track to play on. So int channel. And maybe the channel should be before loop, that way it'll be easier to specify. So channel, and that will default to 0. That'll default to the very first channel possible. And then we'll have a float for the starting volume. If I want it to fade in, then I will leave that at 0f. Otherwise I can set it to 1 and have it start off at full volume. And then I also want a volume cap that I can place on songs. So similar to how we set the volume of voices and sound effects, they will only play at that volume. But we're not fading in voices or sound effects, where we will be fading in tracks. And a track needs to know where it starts at and where it stops at. In other words, how far it can go. What's the volume cap? So we'll also define that for a float in the volume cap. And that's going to be 1 by default, so it can max itself out. And music is something that once we save our visual novel, we're going to want to be able to reload that same song to play once we load whatever game save it is that we created for this visual novel. So just like we did for textures in the backgrounds and all our graphic panels, we also need to be able to save the file path for the audio track. So we'll specify a string for the audio, well, actually we have file path here, so we won't need to pass that in. We will need to for the, when we pass in the audio clip directly. So we've got play track that takes in the file path, and let's duplicate that play track, which takes in a audio clip for the clip. And this one will take in a string for the file path at the very end. And just like we did for our sound effect, we're going to try to load the audio clip first following that file path. If it is null, then we had an error and we'll return nothing. Otherwise, we're going to return the track by passing in the clip, the channel, the loop, starting volume, volume cap, and of course that file path. Which means this function down here is the one where we're really going to start playing the music. The first thing we need to do is we need to try to find the channel at which we play this track on. So let's make ourselves a function that can do that for us. It'll be a public audio channel returning function called try_get_channel. And we're going to take in a integer for the channel, and then we'll also have, we'll call that the channel number, but we're also going to have a boolean called create if does not exist, like we do for our characters in our graphic panels. By default, that will be false, so we'll only get the panel. And so what we'll do in here is we'll go ahead and create a temporary cache for our audio channel, and just make sure that that is null right off the bat. And now let's try to find it if it exists in our dictionary. So if channels dot try get value, and we're going to try to find the channel number, and then we will also try to cast it out into our channel. So if we succeed, then we'll go ahead and return channel because we've already got it and it already exists. Otherwise, let's check if we create if it does not exist. If we create it if it does not exist, then we will go ahead and create a new audio channel. So we will return new audio channel, and we'll pass in the channel for this constructor. That does not exist yet, we'll create it in a second. So essentially we're going to say create an audio channel at this channel number. And then if none of that works, we'll go ahead and return null because we do not have a channel. So in play track, we need to try to get that particular channel listed here. So we'll say audio channel, and we'll call this the audio channel, and set that equal to try get channel, passing in our channel, and saying true to create it if it does not exist. Okay, so let's stop right there, and let's go ahead and define how we create an audio channel. So we need a constructor in here. That constructor is simply going to take in the integer for the channel that's being applied to this newly created instance. So we'll need something to store that in. We'll have a public integer called the channel, and we'll call that channel index just to keep things clean and elaborated. We can get it from anything, but we can only privately assign it from this channel when we create it. And so when we create it, we will say channel index equals the channel that has been passed in. Now, just like we did for our sound effects, they are created in new objects, and those objects are parented to a child specifically for the sound effects. Let's do the same thing for our audio channels. So we're going to make ourselves a track container that will hold any of the tracks that we create for this channel. That's just going to be a game object. So we'll get a public transform called track container, and again, anything can get it, but only this channel can assign it when it's created. By default, that's going to be null, but we need to create it. So we will go ahead and say that track container equals a new game object, and we need to call it something. So we need a naming format for this channel. We're going to go ahead and define a private constant string called the track container name format, and that's going to be a string called channel with the channel inside of brackets. So we'll have string.format, and format the name with the track container name format, and just pass in the channel number to that thing. And once we create it, then we're just going to grab the transform off of that, and we have the track container for all of our objects to be parented to. But we also need to parent this to the actual audio manager. So track container dot set parent, and we're going to set this to the audio manager dot instance, and that will be the transform of the audio manager. So there we go. So in testing, if I just go ahead and create a new channel at channel 1, I need to quickly just go ahead and return null for a second, and that's not channel, that is channel number when we create the new channel. Just go ahead and return null here, that way we can do a quick check. And so we're going to create a new channel at index 1. Then what we wind up with is channel 1 inside of our audio manager. And our tracks can be created inside of that channel now. So the channel is going to need to keep track of the audio tracks that it's using. And we'll do this with a little list here. So private list, and we'll keep our audio track, we'll just call the list tracks, and set that to a new list by default. So our channels should have the capability to directly play a track within themselves. And this is what we'll call from our audio manager once we find the appropriate channel to play the track on. This is going to be a public void, not a void, a audio track. So we're going to create it, and it'll be called play track. So we're going to play the track with an audio clip, or clip, and then we need to get a boolean for loop. We need the float for the starting volume. We need the float for the volume cap. And of course we need the string for the file path for this sound. That way we can save and load it. Now, before we go playing a track, we want to make sure that we don't already have one that is playing for this particular clip. So let's get ourselves a public, we'll return a boolean to see if the track exists, and we'll call this try get track with a string for the track name, and we'll cast out what we find to an audio track called value. Just like you do for a dictionary. And so now let's go through for each var track in tracks and look for something. We need to look for some data in our track. Real quickly, just so we have something to look for, our track is going to need a name. So let's make ourselves a public string for the track name. Nah, we'll just call it name. And this doesn't need to be a mono behavior. So that'll be the name. And of course, we will make that publicly retrievable and only privately assignable. We're going to save that, go back to our audio channel, and now we got something to look for. So if our track.name equals the track name, why don't we make that case insensitive as well? So track name equals track name.toLower. And then let's check the track.name.toLower and see if it's the same thing. If it is, then value equals track, and we'll go ahead and return true, saying that we found a track. If we do not find one, then we'll go ahead and say that our value equals null, because we didn't find one, and we'll return false. So in play track, we need to try to see if we have one. We can easily check this by saying if try get track. And we're going to be looking for clip.name, because the tracks are going to be named after their clips. And we will cast out to a audio track called existing track. We're looking to see if we have one that already exists. If we find one, then we can go ahead and return the existing track. If not, then we need to create one. So our audio track equals new audio track. And then we will return track. But of course, we need to give that some data. So let's jump into our audio track and figure out what this thing needs. Our audio tracks do not need start or update, and they're going to contain some information. So let's make some references to these real quick. The reference to our channel can be private, so audio channel will be private, and we need a audio source. That can be private as well. Audio source, and we'll call that the source. And then we want a boolean to represent if we are looping or not. Now, that can be publicly retrievable, but we don't want that being assigned outside. So public bool loop, and that will be get and private set. And we also need the volume cap. So public float volume cap. Again, get and private set. And now let's create the constructor. Public audio track. And we need some information. Let's go ahead and get the audio clip that we want to play. Let's get the loop value if we want to loop this track. And let's go ahead and get the starting volume, as well as the volume cap. And we also need the audio channel. So as for what we do in here, let's go ahead and assign the name of the audio track to the clip that we are playing. So name equals clip.name. Good. And now let's make sure we associate the channel to this track. So this.channel equals channel. And now we can say that volume cap equals, well, actually that needs to be this.volume cap equals volume cap. And we'll go ahead and say that this.loop equals loop as well. No, you know what? We won't do that. Loop will actually point to the source.loop. That way we just grab it directly from the audio source. Okay, so speaking of audio source, we need to create it now. So since there are several things that we have to do in the audio source creation process, such as set the parent, and some other things that we will add on, we'll make this a separate function, and we'll go ahead and make that private, return an audio source called create source. And this is going to take a string for the name. We don't even need to pass in the name. In fact, we don't need to pass in anything. We're just going to go ahead and create the source. So let's start by creating the game object. We'll call it geo and make that a new game object, and we're going to name it under a particular format. So again, public constant. Why am I making that public? Private. Make things private by default. Good isolation. So private constant string for the track name format. And this is going to equal the track followed by the track name inside of the brackets. Okay, and we will inject the name into that format. Okay, so we'll do the same thing that we did for the channel, and we will set geo.transform.setParent, and we're going to set it to the channel.trackContainer. So it gets parented to our channel. And now we need to add an audio source. So our audio source equals geo.addComponent audio source. And we'll go ahead and return the source. And now that we can create a source, we'll go up to our constructor and say source equals create source. And then source.clip equals the clip, source.loop equals loop, source.volume equals our starting volume. And to control our tracks, we'll make two functions to both play and stop them. Public void play and public void stop. With play, we can just say source.play And with stop, we can say source.stop. So when we decide to play a track from our audio channel, we try to see if the track exists, but if it doesn't, we go ahead and create a new track, which means we're going to pass in the values that we have assigned to this function. We'll pass in the clip, as that's what we want to play, as well as loop, the starting volume, and the volume cap, and then this as the channel. So our audio track has a reference to this channel. And if we decide to create the track, let's make sure that we play the track as well. So track.play. And we're going to start playing it. Let's also make a way to check if it is playing. So public bool is playing, and we will just return source.isPlaying. So then in the channel, if that track does already exist, we could say if not existing track.isPlaying, then existing track.play, and we'll make sure that we restart it, and then return the existing track. So back in the audio manager, we go ahead and grab the audio channel, and now we have a way to actually start the track. So we can call, or we can actually get audio track equals audio channel dot play track, and then we're going to pass in the stuff that we have here. Clip, the loop, starting volume, the volume cap, and the file path, and then return the track. And so now if we go to our testing script, I'm going to go ahead and create Stella on screen, and then make sure I show her, and then we're going to wait for the narrator to ask if we can see her ship. At which point, then we'll transition the background to the ship, and here we are at the audio manager. We're going to play a track called Electric Drift. This one is not one that you'll have, but you do have some provided in the resources. This is just one that I purchased, so I can't give that out. And we'll also make Stella laugh and say yes. Then we'll set her sprites, move her to a position, and she'll say yes, of course. So we should be able to hear music play, and should go ahead and work without an issue. You can find the music that you have from anywhere that you may have imported it, or if you dragged in the folder that I provided in the downloads, it will be under Resources, Audio, Music, and then you'll have this different group of songs here. So if we go ahead and play that, let's see what happens. We get the narrator asking Stella if we can see her ship, and then we click. And we go ahead and transition to the music, and we can hear that playing. And we also heard Stella laugh and say yes a second ago. Now if we jump into the audio mixer though, music is not routing through the music channel because we did not actually throw in that music mixer. Before we do that though, let's talk about the music import settings, because just like we did for sound effects, there's a way that we need to import the music so that way we don't have any kind of freezes as we're loading it and streaming it, or even using too much memory trying to run the music in the background. If you use one of these songs, you may notice that when you hit the line to load the song from resources, you might have a slight delay between your click and when it actually starts playing, because that's going to come through the quality and the load type of the music. When we're working with music, the best settings that we can use is highlight them all and change load type from decompress on load to streaming, and then lower the quality from 100 down to about 70. This is not going to produce any kind of audible difference. It'll sound exactly the same, or at least it does to me. And then you hit apply, but what it does do, even though you don't hear an audible difference, it significantly reduces the requirements to loading it and speeds it up dramatically. Now, as for getting it to play in the audio mixer, we're going to make sure that we just pass in the music mixer for any sort of track that we create, even the ambience, unless you want to create a separate mixer for that, in which case adjust the code as you need it. So we actually do not need to pass it into the parameters for play track on the audio manager. What we do need is we need to pass it in on the audio channel. Actually, not even the audio channel. We need to pass it in on the audio track. So after the channel, we need to pass in a audio mixer group and call this the mixer. And when we play a track from the channel, what we'll go ahead and say is we'll grab the audio manager.instance, and we will pull the music mixer from the audio manager. So we're going to grab that music mixer and use that for every one of our tracks. This is where you would place in a check if you wanted to do ambience or music or what have you. If you wanted to do that, actually, you would throw that check into the audio manager and then you would pass in the mixer from here to the channel. But I'm only doing the music mixer for both audio or for both ambience and music because really they're going to fall under the same categories. And so we pass in that to our mixer, and then for our audio track, what we can then say is source.audio output mixer group is our mixer. So we go ahead and click.
Yeah.
All right. Yeah, and we can see we've got the music, and Stella, of course, said yes. We're going to end that off here, and then the next part, we're going to make our audio fade in and override other tracks when we decide to play a new song. So, see you guys then.